Have you ever imagined a world without heat transfer? It might sound like an odd question, but it's a thought experiment that leads us down a fascinating rabbit hole of hypothetical physics. Heat transfer, the movement of thermal energy from one object or substance to another, is a fundamental process underpinning life, technology, and our very understanding of the universe. Let's consider three primary ways this process occurs: conduction, convection, and radiation. These are the invisible forces responsible for everything from the warmth of the sun reaching our skin to the cooling of a steaming cup of coffee. Now imagine a universe where this process is absent. The most immediate consequence would be a lack of temperature equalization. No longer would objects cool down or warm up due to their environment. This would result in extreme temperature disparities. In this strange new world, every process would be adiabatic, a term from our current understanding of thermodynamics that describes a process where no heat is transferred to or from a system. The only way to change the internal energy of a system would be through work done on or by the system. Life as we know it would be drastically different. Plants would be unable to use sunlight to perform photosynthesis, and animals could not rely on their environment to regulate their body temperature. The delicate balance sustaining life would be severely disrupted. The impact on technology and engineering would be equally profound. Every machine, every structure designed with heat transfer in mind would suddenly become obsolete. Engines, for instance, that rely on heat transfer for efficiency would cease to function as intended. The Earth's weather systems, driven by heat transfer, would also come to a standstill. Without convection, there would be no wind, no rain, no storms. The Earth's climate would become static. Even the stars would be affected. They function through the transfer of heat from their core to their surface and then into space. Without heat transfer, they could not radiate energy, and the universe would be plunged into darkness. Now that we've set the stage, let's dive into the details of heat transfer and its importance. Heat transfer is a fundamental process that governs our reality. This process involves the movement of thermal energy from one object or substance to another, and it unfolds in three key ways: conduction, convection, and radiation. First, let's talk about conduction. Picture this: you're holding a metal spoon in a steaming bowl of soup. The spoon becomes hot, doesn't it? That's conduction in action. It's the process of heat transfer through direct contact. The thermal energy from the soup is transferred to the spoon and then to your hand, all via the particles in these substances vibrating and colliding with each other. Next, we have convection. Ever noticed how it's warmer near the ceiling of a room than it is near the floor? That's because warm air rises while cooler air sinks. Convection is the heat transfer that takes place within fluids, including gases, due to the movement of their particles. The warm air rises because it's less dense than cool air, and this cycle of rising and sinking creates what we call a convection current, distributing heat throughout the room. Lastly, there's radiation. Despite what the name might suggest, it's not just about radioactive materials. In fact, radiation is the only method of heat transfer that can occur in a vacuum like space. It's how the sun's heat reaches us here on Earth. Radiation involves the transfer of heat via electromagnetic waves, without the need for any medium or contact. It's important to note that these three methods often work together. For instance, when you heat a pot of water on the stove, the burner conducts heat to the pot, the water inside the pot is heated by convection, and any excess heat is radiated into the surrounding air. So heat transfer is constantly happening around us, but what if it didn't? Let's explore that in the next segment as we delve into the intriguing world of a universe without heat transfer. Without heat transfer, our world would be drastically different. Consider the concept of adiabatic processes. In our current understanding of thermodynamics, an adiabatic process is one where no heat is transferred to or from the system. In a world without heat transfer, every process would be adiabatic by default. The only way to change the internal energy of a system would be through work done on or by the system. Now, let's think about life on Earth. It relies on heat transfer in more ways than we often realize. Plants, for instance, use sunlight, a form of radiation, to perform photosynthesis, while animals depend on the environment to regulate their body temperature. Without heat transfer, the delicate balance that sustains life as we know it would be disrupted. And what about technology and engineering? The design of every machine and structure takes heat transfer into account. Engines, for example, rely on heat transfer to work efficiently. and buildings are insulated to maintain comfortable temperatures. Without heat transfer, these designs would be obsolete. The consequences would extend to the Earth's weather systems as well, which are driven by heat transfer, particularly convection. Without it, there would be no wind, no rain, and no storms. The climate would be static, and the dynamic processes that contribute to the Earth's habitability would cease. On a grander scale, the absence of heat transfer would have profound astrophysical implications. Stars, including our Sun, function through the transfer of heat from their core to their surface and then into space. Without heat transfer, stars could not radiate energy, and the universe would be a dark and cold place. These are just a few examples of how essential heat transfer is to our existence. It underscores the intricate interdependencies within the universe and the delicate balance that makes our world habitable. So the next time you enjoy a warm cup of coffee, remember that without heat transfer, such simple pleasures would not be possible. In a universe without heat transfer, we'd need to rewrite the laws of thermodynamics. Imagine a world where heat doesn't flow from hot to cold, where a snowflake wouldn't melt in your hand, and where a cup of tea wouldn't cool down to room temperature. In this peculiar universe, the laws of thermodynamics as we understand them today would be thrown out the window. The concept of entropy, for instance, would be irrelevant. Entropy is a measure of disorder or randomness in a system and is closely related to heat transfer. It's what makes heat flow from a hot body to a cold one, leading to an increase in the total entropy of the system. This is the second law of thermodynamics, which states that in any energy transfer or transformation, the total entropy of a system will always increase over time. But in a world where heat doesn't transfer, there's no change in entropy. Everything remains in its initial state of order or disorder, and the second law of thermodynamics becomes obsolete. In this theoretical universe, energy would still be conserved. The first law of thermodynamics, which states that energy can neither be created nor destroyed, would hold true. However, the way this energy is distributed and utilized would follow entirely different rules. Without heat transfer, energy could only be transferred through work. This means that to change the internal energy of a system, work has to be done on it or by it. The concept of work in physics involves force and motion. So, in this universe, the movement of objects and the forces acting on them would play a far more significant role in energy exchange. This hypothetical scenario also suggests that systems could remain indefinitely in unstable equilibrium states. A hot cup of coffee, for instance, would stay hot forever unless some work was done on it. Similarly, a cold drink wouldn't get warmer unless some external work was done on it. This theoretical perspective shows how vast the implications would be if heat transfer didn't exist. It's a fascinating thought experiment that underscores the fundamental importance of heat transfer in our universe, shaping everything from the movement of energy, the behavior of systems, to the existence of life itself. The absence of heat transfer is more than just an intriguing thought experiment. It's a journey into a universe where the rules of thermodynamics are rewritten, where every process is adiabatic, and where entropy no longer holds relevance. It's a world where life as we know it, the technology we rely on, and the weather systems we experience would all be drastically different. In this hypothetical scenario, temperature equalization ceases to exist, leading to extreme disparities. The delicate balance that sustains life on Earth would be disrupted, as plants could not photosynthesize and animals could not regulate their body temperatures. Our technological advancements would become obsolete, as machines and structures designed with heat transfer in mind would fail to function as intended. Even the stars in the sky would not shine, as they could not radiate energy without heat transfer.